In our previous video, we were working on a problem where we had 950 students in a sample of college students, and 53% of them said that they take online courses. We built a 95% confidence interval to estimate the proportion of all college students who take online courses, and we found that somewhere between 49.8% and 56.2% would be where that unknown population proportion is likely to fall. Now, we had a follow-up question to this problem that asked, based on the confidence interval obtained in Part B, we cannot safely conclude that more than 50% of undergraduates take online courses, because to say that more than 50% of them do would be violated if P actually fell in the interval closer to 0.498. In other words, if this interval dips below 0.5 to any degree, then we cannot say for certain that more than 50% of college students take online courses. If our interval had instead been something like 0.512, I'm just making this up as an example, then yes, if P is likely to fall between these two values, then certainly above 0.5 would be more justifiable. Here's another way of looking at a confidence interval and its anatomy. If we have a confidence interval already given to us, such as what we had in the previous screen, we can find P hat, the initial point estimate, that sample proportion, by calculating the midpoint of the confidence interval. Remember that P hat is right smack in the middle of the confidence interval. So we would just add the upper and the lower bounds of the interval and divide by 2, and that would give us the midpoint P hat. If we have a confidence interval and we're trying to calculate that margin of error, then remember, a margin of error is one of those arm lengths reaching from P hat out to either of the two bounds. So to calculate the margin of error, we can take the length of the interval and divide it by 2. The length of the interval is the upper limit minus the lower limit, and then dividing that by 2 would give us the arm length. So remember my little stick figure analogy. If the stick figure is right at P hat on the number line, then adding the lower and the upper bounds and dividing by 2 would give you the midpoint P hat. And the arm length is equal to E. So if we know what the interval is and we're trying to find the margin of error, then we can take the distance from the lower to the upper bound, which is a simple subtraction, divide that by 2, and that would give you the arm length, which would be E. Let's look at the following example. It says that of the 71 subjects, 70% were abstinent from smoking at 8 weeks. And this is a 95% confidence interval. Use that statement to find the point estimate P hat and the margin of error E. So let's write a few notes here. First of all, we have that the sample size is 71, and the 95% confidence interval, and we'll use CI as an abbreviation, went from 58% to 81%. To find P hat, we would just take the midpoint, so that would be 0.58 plus 0.81, and divide that by 2. And to find the margin of error, we would take the distance from one corner of the interval to the other and divide by 2. So that's 0.81 minus 0.58 divided by 2. So here we see the calculation for P hat, that is our midpoint. Add the two limits, divide by 2. So P hat would be 0.695. And here in the next slide, we have the calculation for the margin of error E. Take the distance from one corner of the interval to the other by subtracting, then divide by 2, and we find that the distance from the center to each one of the two limits is 0.115. So an alternate way of writing this interval, we see here that p hat is 0.695 and that e is 0.115. We could write it as p hat plus or minus e, or 0.695 plus or minus 0.115. Now let's talk about how to determine a sample size needed for a study.